Well, hello there, mathematicians, and welcome to another exciting episode of Math Notes. Today, I am your host, Mr. Pratt, and we will continue our study of systems of equations. Today is Tuesday, April 28th. It is day 12 of our systems unit, and today is a big day. It's a huge day. Today, we're talking about solving systems by elimination. Elimination is an incredibly important algebraic concept. We're going to keep using elimination and later its brother substitution consistently for years in math. I can't wait for you guys to get good at it, but a fair warning, there's a number of steps to these problems. The first couple times you see it, it may feel like a lot. However, once you've practiced it multiple times, it will feel easy, it'll make sense. But just so you're warned ahead of time. So, top of your notes look like this. Let's see here. We're going to fill in the blanks together. Fill them in as we go. I'm going to talk through them. But as we do examples, they'll start to become clear. But let's fill in each of ours first. Here are the steps for solving systems using the elimination method. We're going to have two equations, as you can see in example A below this. You're going to start by lining up your x and y values. Then you're going to look at the coefficients. Now, coefficients are a big word in math that mean the number in front of the variable. If we're looking to see if they have opposite coefficients. Opposite, of course, like a 3 and -3 or -10 and 10. If they don't have opposite coefficients, then we're going to multiply one or both of the equations by a constant to make the coefficients opposites. Now, if they do already have opposite coefficients, then we skip step 3. But oftentimes they don't, and we have to multiply one of the equations to make them opposites. Once you have opposite coefficients, add those equations together to, here's the big word, eliminate one of the variables. Mr. Pratt, I'm confused. What are you talking about? Don't worry, we'll do an example. I'll walk you through each one. Let's just fill this in. Once we've eliminated one of the variables, solve for the other variable. Solve for the remaining variable. So if you eliminated x, solve for y. Substitute the value you found into one of the original equations and write your answer as an ordered pair. Those are our steps, and we're going to do 3 examples here and go through those steps together. So here's example A. 2x plus 5y equals 17, and 6x minus 5y is -9. Let's go through step 1. Line up the x and y values. So, okay, I've done that. I lined them up vertically. Step 2. Does one of our variables have opposite coefficients here? 2 and 6, they are not opposites. What about y? Does y have opposite coefficients? Hey, look at that. It sure does. Plus 5y and minus 5y, opposite coefficients. So they do. So we're going to skip step 3. Step 4, if you have opposite coefficients, add the equations together. So with me here, let's draw a line, just like we would add 2 numbers, a little plus sign there, and add them vertically. So 2x plus 6x is 8x's, and 17 minus 9 is 8. The y's have canceled. Look at that, we eliminated the y values. So 8x is equal to 8. Fantastic. Solve the remaining variable. You all know how to do this. We're going to divide both of these sides by 8 to isolate x, and that means x has to be 1. Wahoo! We solved for one of our variables already, and it was a pretty simple, straightforward process. But we need to solve for y as well. So what do? Substitute the value you found, x is 1, into the original equation to solve for the other variable. So I take my original equation, 2x plus 5y equals 17, and I've written it again, but I substituted x for 1. 2 times 1 is just 2, plus 5y equals 17. And if I subtract 2 from both sides, I'm left with 5y equals 15. Well, we know how to solve from there. Let's divide both sides by 5, and y is equal to 3. Hey, we have both x and y. Let's write our ordered pair. We said x was 1 and y is 3, so our ordered pair is 1, comma 3. Da, 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 da. Ladies and gentlemen, you did it. You have, with me, solved a system of equations through elimination. Congratulations, well done. And it only gets easier from here. Let's try the next one. Example B. We're given two equations. All right, how do we solve for two different variables in two different equations? That's crazy. Glad you asked. We're going to do it through elimination. So, step one, same as it was before, line up your x and y values. So if you'll write them just like this. Ladies and gentlemen, please at any time feel free to pause this. I am going quick because I don't want the video to be too long. So as a general practice, pause my videos, rewind, whatever you need. Now, let's go on. Look to see if one of these variables has opposite coefficients. So does x have opposite coefficients? No. 3 and negative 2 are not opposites. Does y have opposite coefficients? No. They're both positive. But I can already tell, what if I just made one of those 4s negative? Then they would have opposite coefficients, right? So that is step 3. If they don't have opposite coefficients, we multiply one of the equations, or both sometimes, by a constant to make the coefficient opposite. So I'm looking at these 4s. I want to multiply by negative 1. If I do that, the negative 1 will be distributed to every value in the parentheses. The equation stays true because I've multiplied both sides, but the 4s will then have opposite coefficients. So I rewrite my problem, 3x plus 4y is 18, that didn't change. But the bottom, now the negative 2x is positive 2x, the 4y is now negative, and the negative 1 distributed to the 8 as well, it's negative 8. So check that out. Now I have opposite coefficients. Now I can add them together, just like we did last time. The 4y's will cancel, and 3x's and another 2x's makes 5x's, just like Jasmine has. And this is equal to 10. Great, let's solve for x. Should be pretty easy. We're going to divide both sides by 5. X has to be equal to 2. I love it when they're nice whole numbers and they're nice and small, like 2 or 1 or 4. Substitute that value back into the equation. So we get 3 times 2 plus 4y is 18. I multiply the 3 and the 2. I subtract 6 from both sides. All I have left is 4y is 12. And everybody knows what's coming. Say it with me. 1, 2, 3. Divide both sides by 4. You're exactly right. Well done. If we divide both sides by 4, y is 3. Ladies and gentlemen, we have x and we have y. So we're going to write our answer as an ordered pair. Since x is 2 and y is 3, the ordered pair is 2, 3. That's it. That's example B. And that's almost as hard as they get. Let's look at example C, which is the hardest of the examples. Maybe not the hardest, just has the most steps. And let's write these out one at a time. So step 1, you've got it on your notes, says line up the x's and the y's. Now in this case, our equations are not in standard form. So I have rewritten them to be in standard form so I can line them up. I've moved the 2y to the left by adding 2y to both sides, and I've moved the 6 to the right. So I've rewritten that equation to be 4x plus 2y is 6. I did the same over here on the right when I rewrote it. I want the x's to line up, so I left the x in front, but I subtracted y to move it to the left and subtracted 9 to move it to the right. Now my variables line up. Once my variables line up, I look to see if a variable has opposite coefficients. Coefficients of x are 4 and the invisible 1. They are not opposites. The coefficients of y are 2 and the invisible negative 1. Again, not opposites. So they do not have opposite coefficients. So we multiply one of the equations or both by a constant to make them opposite. So in this case, I'm going to multiply the bottom one by negative 4. I know that negative 4 is the opposite of positive 4. So as I distribute this -4 to each value inside the parentheses, I rewrite my equation. The top stays the same, but the bottom is now -4x plus 4y and positive 36. Each value has been multiplied by -4. And I can see that I now have opposite coefficients, which means that I can add them together like we've been doing. The x's this time will cancel. It doesn't always have to be the y's. And I add up the y's. I now have 6y is equal to 42 because 6 and 36 makes 42. Well, let's solve for y. It's the one that's left over. We'll divide both sides by 6, and y has to be 7. 42 divided by 6 is 7. That's one we should all memorize because it's a toughie. Once I know y, what do? Well, I plug it back into the equation to see what x is. So I rewrite my original equation, or my first equation. But instead of y, I now have 7. Multiply the 2 and the 7 to make 14. Subtract the 14 to isolate to isolate x, get that out of there. Divide both sides by 4, and that means x must be -2. Hey, we're done. So x is -2 and y is 7. We'll write it as an ordered pair. And since ordered pairs are always x comma y, this answer is going to be -2 comma 7. Now, ladies and gentlemen, we are officially finished. And you have a 5-problem assignment. However, elimination is not the easiest concept in the world the first time you see it. I encourage you, watch this video multiple times if needed, but also look up other videos on YouTube, on Google, if they will help you with elimination. All of the videos you find, because elimination is pretty standard and pretty specific, will have the same basic steps. And if you want to see more examples, there are hundreds of videos you can find online that can help you in addition to this one. So good luck. Get that 5-problem assignment done. Let your teacher know. We hope all of you are doing really well and taking care of yourselves. We miss you and hope you have a wonderful school year, and we'll see you next time.